So we're starting into trigonometry in 20-1. And this unit is kind of split into two main ideas. There's the main idea on angles and a unit circle, which is going to get carried on to 30-1. And then there's our continuation of our SOHCAHTOA. So we're going to work a little bit further with sine law and cosine law. And there might be a little bit of interruption within this lesson just because my lab has decided he wants to help. So the first little lesson here is just on rotational angles. So rotational angles are always going in a counterclockwise direction if they're positive. So they're going to open to the left, whereas a negative one is going to go clockwise, so it's going to go around to the right. And a standard position angle is going to be essentially the angle that's drawn without having to work on some other words like coterminal reference and ones like that. So the diagram here, I always start right here on my x-axis on the right-hand side, the one between quadrant 1 and 4, and then I open in the counterclockwise direction to a 220-degree angle. So that's a standard position angle. So right now they just want me to draw the angle for each of these. So they said 0 or 120 degrees. So if this is my start line, then going 120 degrees is going to open up in my quadrant 2, because quadrant 2 goes from a minimum of 90 to a maximum of 180. And 309, if I start again, here's my start line, going 300 degrees is going to end me in this quadrant, because that quadrant goes from 270 to 360. And then 17 degrees, if this again is my start line, then this right here would be my 17-degree angle. And state which quadrant it is. So this is quadrant 1. So quadrant 1, quadrant 4, quad 4, and this would be quadrant 2. So then moving on to the next one, we're going to talk about some other words. So coterminal angles are angles that are the same place. So they are going to give you the same end point, but they're going to be written as something else. So this is going to be essentially their equivalent, if you want to think about it like that, equivalent angles. So like equivalent fractions, like 1/2 and 3/6, they mean the same thing, but they look different, or say use different numbers. This is what this is. So it says to draw a rotation of 150. So there's my start, and there's my 150 right there. Then it says -210. So all negative does is it opens clockwise instead of counterclockwise. So I'm going to open this way instead and go 210 degrees, which is again still there, but I've gone in the negative direction this time. Or 510, so 510 is going counterclockwise. So there is 360, 5, 4, there we go, 510. So 360 to 450 to another 60 past, which is 510. So those are coterminal angles. They all look the same, but they use different values to get there. And the one that has the smallest positive is called the principal angle. So the principal angle has to be less than 1 full rotation, so it can't be anything more than 360 degrees. And yeah, there are tons of coterminal angles. There's not like there's only 3. You could go a positive rotation, you could go a positive full rotation, and then another full rotation. You could go more than 1 negative full rotation to get to it, but that's how that one works out. So coterminal are just angles that look the same but use different values to get there. If they give you points in this unit, you have to put the points on a coordinate plane grid. So anywhere you would normally put it. So this one's going to go to 2 and -4. So there's P right there at 2 and -4. And I'm always going to use my origin, my 0, 0 point as my other one to connect my line. And there would be my angle in standard position. If I had -5, -1, I have 1, 2, 3, 4, 5, -1. So I have my point right there. And I always, again, use my 0, 0. So there's my point P, which is at -5 and -1. And drawing my angle in standard position, it would open up like that. So reference angles are another type. They specifically have to be between 0 and 90. So a reference angle has to be between 0 and 90. So similar with a principal angle has to be between 0 and 360. A reference angle can only be 0 to 90. So it says here I have my standard angle of 141 here. And I have a reference angle of 39. Now, a reference angle is always off the x-axis and my arm, so my angle arm. So that right there is my reference angle. So that right there is my reference angle. So for these ones, I want to draw my standard angle. Stop. Come here. No, you can't draw on my board for me. So here I want to draw my reference angle in. So I have 243, which is right there. That would be my standard angle. And then I need to go draw my reference angle. So my reference angle is always between my x-axis and my arm. So there's my x-axis, and there's my arm. So I need to try to figure out how big my reference angle is here. So if my regular angle has gone past, so if my regular angle here is 243, and I know that my reference angle is from 180 to that, I can figure out my reference angle by taking my whole angle there and subtracting off the 180 to figure out how far past 180 I went to get to that arm. And so I would have gone 63 degrees past it, and so my reference angle here would have to be 63. If I had 337, I'm looking at, I went 337 degrees. There's my standard angle. And I have to figure out my reference angle. So again, my reference angle is between my x-axis and my arm. So my reference angle is that one right there. So that right there is my reference angle, and I have to figure it out. So with this one, I know my reference angle is made up of my 360 and my arm, and I can figure out how much that is by taking my 360, which would be where it would go to next, and taking away what I have, which is 337 degrees, and that would leave me with a 23 degree angle to be my reference angle. And then if I look at my last one, I have a 70 degree angle right here, and I wanted to do my reference angle. So again, my reference angle has to be my x-axis to my angle arm. So my reference angle here happens to be the exact same thing. So my reference angle is 70 degrees. So now it says on the grid, draw a reference angle of 58 degrees in each of the quadrants from 1 to 4. So remember, a reference angle is from our axes up. So there's my reference angle of 58 degrees in quadrant 1. Then in quadrant 2, I have it from my x-axis up. So that's 58 degrees. And then quadrant 3, I have it from my x-axis down. So x-axis down would be 58 degrees. And then I have it in my last quadrant, again from my x-axis down. So that would be 58 degrees there. So we've drawn them all from quadrant 1 to 4. So now they want us to state the actual standard angle in each of those quadrants. So if I looked at quadrant 1 here, given what I drew, I have my angle right there, and that would be 58 degrees. So in quadrant 1, it'd be 58 degrees. In quadrant 2, I had that angle there, but I want this measurement right here. So to find my standard angle in quadrant 2, I would go 180 minus 58 because that's 58 off the 180 line. And that gives me a standard angle of 122 degrees. If I look at quadrant 3, that's in this one right here. I'm looking for this measurement here. I know this little guy here is 58. So for this one, I can add my 58 on, and that would give me a standard angle of 238 degrees. And then in my last quadrant, I'm looking for this one right here as my standard. I know this is 58. So to find my last standard angle for quadrant 4, I would have 360 minus 58, and that would give me a standard angle of 302 degrees. So that would be all of my standard angles and my reference angles. And then remember, coterminal means it's the same angle using a different way to express it. So they've given me a point. So I'm going to go right into my coordinate plane and throw my point on there. So I have a point at 3 or 5 and 8. So it's going to look around here. So P at 5, 8. There's my standard angle right there. So now it says is on the terminal arm in quadrant 1. State the coordinates of the points which are on the terminal arms of the rotation angle in quadrants 2, 3, 4, and 5. So with this, these are reflections. So I am reflecting it. So if I reflected it on this axis, this point here would then become -5, +8. But it would keep the same angle there because it'd have to be a reflection. If I reflected that angle onto the bottom here, which would again keep the same angle measurement because that's what a reflection does, is it keeps it the same distance, that would make this point 5, -8. And then I'd have to reflect one more of them into this quadrant here. And again, because I'd be reflecting either this one or this one, it doesn't matter. It would give me the same answer, which is -5, -8. And that would give us our 4 reflections with the same reference angle in each quadrant. So going on to the last little example here, which is just recapping all of this together. Reference angles are very important, so knowing them is good. So they're giving me the reference angle, they're giving me the quadrant, and I have to give you what the standard angle is. So there's quadrant 2. There's a 25-degree angle. I want that. So this would be 180 minus 25, and that would give me a standard angle of 155 degrees. If I had a 60-degree angle in quadrant 4, there's my 60-degree angle. I want the rest of it. So that would be 360 minus 60, and that would give me a standard angle of 300. And then if I went on to the next one, I have 8 degrees in quadrant 3. So that's 8 degrees. I want that measurement. So that would be 180 plus 8. which is 188 degrees. And then if I had 39 degrees in quadrant 1, so that's 39 degrees right there, that would be just the same value. And then my last one, it says 90 degrees between quadrants 3 and 4. So there's 90 degrees right there. So then my standard angle is right there. And that is 180 plus 90, which is 270. So now it says for the last one here, determine 3 angles between 0 and 360, which have the same reference angle as 256. So if we drew in 256, which would be right there, and found our reference angle, that will help us solve the problem. So there's 256. So our reference angle is between the x-axis and the arm. So there's our reference angle. And for this one, because we're past 180, we'd go 256 minus 180, and that gives us 76 as an answer. So our reference angle would be 76. So now we have to go through the rest of the quadrants that we have. So we would have quadrant 1, which would just be whatever it is, so 76. We'd have quadrant 2, which is right there. And we know this is 76. So my quadrant 2 angle would be 180 minus 76, which gives us 104. And then we have our last one, which was quadrant 4. And that is right here in my last quadrant. So this would be 76. And I'd have to go that way. So to find this one, it would be 360 minus 76. So 360 minus 76 is 284. So this would be, sorry, not 280, yeah. So 360 minus 76 is equal to 80, which would be 284. So there's my last one, 284. So that's those angles right there. For the homework, check the PDF file to see what questions have been assigned as practice out of your workbook, and make sure you know how to find a reference angle, and you can draw a standard angle.